I'm standing here with Clement Cid from Caltech in the States.
Hello.
This project is called Caltech Self-Contained PV-Powered Domestic Toilet and Wastewater Treatment System. And my first question to you is, what makes your project stand out amongst the others? What's the special thing about it that makes it unique?
Our key disinfection unit is actually using electrochemical disinfection. We use the chloride from urine and we oxidize this to chlorinated species, and these are basically what you find in bleach. So it's an active disinfection. Our rejection product are only gases, so CO2, methane, nitrogen. What also the different thing we have is we can use any kind of toilets. So we love the S-trap because it doesn't smell. And so in the unit we have here at the fair, it was done in collaboration with Color. So we use regular Color fixtures for the Indian market, but also we can use public toilets. So that's what we did in collaboration with Aram.
And how well has it worked in practice? What are your successes so far?
So we have been field testing on campus our other prototype for the last 6 months. We have people coming and going to the bathroom. We were worried about the amount of solids deposited at the end, but actually we didn't observe any that we couldn't treat. So we can do the treatment, full treatment, in 3 hours, and actually we see disinfection. We see no bacteria residual after half an hour, and same for the viruses. And even if we let, once our water is disinfected, if we let it stand for 2 weeks, we remeasure the amount of bacteria, and we don't see any. So it's a very successful disinfection method.
Okay. What about the biggest challenges or frustrations that you've had to overcome, or that you're still struggling with now?
Well, for example, I would say just for the building of the prototype, we had to build this prototype and another one in only 1.5 months, because that's when the funding came in and when we started having it built. So that was a challenge, getting everything together and making sure that our electronic parts are working, and then making sure that the unit will be able to communicate with us during field testing.
And where are you at in terms of years to implementation, technology readiness level? How many more years until this could be used on a large scale?
So right now we're going to have 2 prototypes in the field. The one we are showing at the fair in Kottayam, in a university setting, but with outside people using it, because there is an exam center over there. And then the other unit is going to be in a park, in a public park in Ahmedabad, in collaboration with Aram and the municipal corporation over there. We're planning to have 5 more prototypes, alpha prototypes. This one is kind of like a pre-alpha, by the end of this year, so end of 2014, and then a commercialization plan by the end of 2015. We're already talking with several industrial partners for manufacturing locally, and moving forward towards something that's more industrial, more compact.
Have you had any collaborations with any of the other grantees that are here?
Actually, we collaborate actively with 2 grantees. We collaborate with Aram Scientific Instrument for the user interface for a public toilet in Indian setting. And we also collaborate with the Bristol Robotics Laboratory, who's providing us microbial fuel cell stack that we are actually testing on campus. So for them, it's their first field testing, and for us, having a microbial fuel cell, treating the urine can avoid some of the electrochemical treatment, so it's a benefit on the energy usage.
Great, thank you very much.
Thank you. Thanks, Susanna.